Welcome back. In this video, we will quickly summarize the atomic structure, the various formulas used for calculation of for solving problems asked in GATE, CSIR, NEET or JEE, etc. For example, we will quickly revise how many lambdas in n orbit, how many revolutions electron can make in 1 second, a relation between lambda and kinetic energy, Heisenberg uncertainty principle, and Schrodinger wave equation, quantum mechanics, and photoelectric effect, Davisson-Germer experiment, and Compton effect, etc. Okay, now we will come to the first part. How many wavelength in n orbit? For example, how many wavelength in n orbit? That is, for n equal to 1, for n equal to 1, only one wavelength will be there. For example, n equal to 3, I have shown there are 3 wavelengths. For example, what is wavelength? The distance between the two crests or two troughs. I have shown here the distance between two crests. Similarly, 1 wave, 2 wave, 3 waves. For n equal to 10, then there will be 10 wavelengths. Okay, a problem may be asked on this. So how, for example, 2 pi r, this is 2 pi r, the circumference of the circle 2 pi r equal to n lambda. For example, the radius, radius of the nth orbit, this is for example nth orbit, then 2 pi r m equal to n lambda. Okay, now we can calculate similarly from the radius of the, what is the n? For example, they have given the radius of the orbit, board orbit, and they have given wavelength. You can calculate the value of the orbit. What is the orbit? They will ask problems. Using this simple formula, they will ask several types of questions. Okay, now let us come to second part. How many revolutions electron can make in 1 second? Okay, how many electrons make electron? For example, the distance traveled, what is the distance traveled in 1 second? Divided by 2 pi r, that is 2 pi r. For example, n equal to 2, velocity of the orbit. For n equal to 2, the electron, velocity of the electron in the orbit 2, divided by 2 pi r. 2 pi r is the circumference of the n equal to 2 orbit. So we can calculate the how many revolutions it can make. Distance traveled per second divided by the circumference of the circle of the particular nth orbit. Okay. Now relationship between lambda and kinetic energy. What is the relation between the wavelength and kinetic energy? According to de Broglie relationship, we know that lambda equal to h by mv. Okay. Now P is equal to mv. The linear momentum is given by m into, according to classical physics, linear momentum is equal to mv. Okay. Therefore, we can substitute kinetic energy is equal to 1 by 2 mv square. You multiply on both numerator and denominator by m. Therefore, mv square by 2m. Therefore, mv square, mv equal to p. Therefore, P kinetic energy equal to, we have not substituted here, kinetic energy into 2m. Therefore, you can calculate. For example, several problems are asked based on this. You will be given lambda. What is the kinetic energy of nth orbit? What is the kinetic energy of the nth orbit? Or you will be given kinetic energy. Calculate the wavelength of the electron in the nth orbit. Its kinetic energy is asked. Okay, now let us talk about Heisenberg uncertainty principle. Heisenberg was given Nobel Prize for his contribution to quantum mechanics. Okay, for his contribution to quantum mechanics. According to him, it is impossible to find the position of the momentum and the position and momentum simultaneously. At the same time, with accurately, it is impossible to determine the position and momentum simultaneously with accuracy. If position is determined with more accuracy, then the momentum, there will be uncertainty in the momentum. Okay, therefore momentum P equal to del x delta A. According to Heisenberg uncertainty principle, the product of uncertainty in position and the momentum is greater than or equal to h by 4 pi. He has shown that he was given Nobel Prize for his extraordinary contribution to quantum mechanics and quantum physics or quantum chemistry, we can say. Next, after the birth of quantum mechanics, quantum mechanics was used to solve for hydrogen atom problem. For example, quantum mechanics, Bohr has used classical mechanics to solve the energy levels, to calculate the energy levels of hydrogen atoms. In quantum, Schrodinger used quantum mechanics. He used quantum mechanics to solve the, to obtain the energy levels of hydrogen atoms. To obtain energy levels of hydrogen atom. What is quantum mechanics? Quantum mechanics nothing but it uses operator. It uses operator. For example, h cap psi equal to E psi. This is known as Schrodinger wave equation. This is known as Schrodinger wave equation or eigenvalue equation or Hamiltonian equation. H cap is the Hamiltonian operator. It is nothing but total energy operator, kinetic energy operator and potential energy operator. When it operates on a function psi, it gives the energy values, energy levels of hydrogen atoms and the observed value and the wave function. What is wave function? It is often asked, what is wave function? Wave function is nothing but a mathematical function used to describe the state of the motion, the state of the system, or used to describe the motion of the electron, the movement of the electron in the hydrogen atom. Psi is a wave function used to describe the motion of the electron in the hydrogen atom or in any atom. Okay, he was given Nobel Prize. Again, many people won Nobel Prize in atomic physics. For example, Schrodinger derived this equation. This equation actually H cap, kinetic energy operator plus potential operator. If we substitute this d square psi by dx square, d square psi by dy square, d square psi by dz square plus a pi square m by h square e minus d psi equal to 0, where E is the energy of the system, D is the potential energy of the system. This equation is called Schrodinger wave equation. This is nothing but a second order differential equation. For y you have three variables. Psi is a function of, for example, psi is a function of x, y, z. Therefore, there are three variables. Therefore, there are three quantum numbers. For particle in a one-dimensional box, for example, if a particle, if an electron in one-dimensional box, it moves only in x direction, then there will be one quantum number. For example, for electron moving in two dimension x and y, then it will have two quantum numbers. Here, the particle is allowed to move in three dimension x, y, z. Therefore, there will be three quantum numbers. This is a common question asked in say various competitive examination. On solving this second order differential equation, Schrodinger, he obtained three quantum numbers by solving. For example, if you solve any equation, you will get solutions. Similarly, on solving this Schrodinger wave equation, he obtained three quantum numbers: n, l, m. They are principal quantum number. N is principal quantum number. L is azimuthal quantum number. M is the magnetic quantum number. Okay. S is not obtained from this equation. S is obtained from is a classical. For example, an earth spins around its own axis. Besides its linear momentum, like a top. So electron also spin either in clockwise direction or in anti-clockwise direction. If it spins in clockwise direction, its spin value is plus half. If it spins in anti-clockwise direction, then it is the magnitude of S is minus half. Okay. Now, what are the values? On solving this mathematical equation? By mathematical condition, n can be 1, 2, 3 up to infinity. L can be 0 to n minus 1, and you are studied in your textbook. But these are all come from solving the Schrodinger wave equation. Nothing. Okay. And M magnetic quantum number can have values minus L through 0 to plus L. Total M values is equal to 2L plus 1. Okay. Now, what is a radial node? For example, radial node for 1s orbital, there will be no radial node. If you look at 2s orbital, it will have one radial node. Therefore, you can use the formula n minus L minus 1 to calculate the radial node, angular node. For example, as I told, p orbital. S orbital has no angular node, L equal to 0. For p orbital, it is L equal to 1, therefore one nodal plane. What is node? Node is a nodal point or nodal region or nodal plane. We can call, for example, in the angular node, it will be a nodal plane. For d orbital, L equal to 2, therefore there will be two nodal planes, angular nodes total number of nodes equal to n minus 1. Nodal regions are nothing but regions where there is the probability of finding the electron or probability density is 0. The probability of finding the electron is 0. Okay, in that plane, for example, on xy plane, if it is in the PZ orbital, xy plane is the nodal plane where the probability of finding the electron is 0. Okay. Now let us come to Aufbau principle. What is Aufbau principle? The order of orbitals. In the case of quantum mechanics, Schrodinger wave equation, the orbitals are obtained. Whereas according to Bohr, the electrons revolve around in a two-dimensional circular orbit. Whereas we have these are all orbitals are obtained from solving this Schrodinger. Next, what is psi? I forgot to tell what is psi. Psi is a wave function. For example, wave function, it will have plus value, negative value, so it has no physical meaning at all. It has no physical meaning. Whereas psi square has a physical meaning. On squaring the psi, you will get psi square probability density or probability of finding the electron. That is your orbital, s orbital diagram. This is on plotting the wave function. On plotting the wave function, you will get the shapes of the orbital. For example, angular wave function, radial wave function. Angular wave function will give you the shapes of the orbital. Radial wave function will give you the radius of the orbital. Okay. Now let us see about Aufbau principle. In the order of orbitals are arranged. The order of orbitals are arranged in the increasing order of energy based on n plus n value. For example, you have 3D orbital and 4s orbital. Why 4s orbital is less energy than 3D orbital based on this. Similarly, you have n plus, for example, 2 orbitals, 3s orbital and 2p orbital. Both have the same n plus n value, but the orbital with the lower n value is considered as the lower energy. Okay, for example, 2p orbital and 3s orbital, they have both n plus l value same, but 2p is lower in energy because n value is lower compared to these two orbitals. Okay, we can calculate Hund's rule of maximum multiplicity. For example, for degenerate orbital, degenerate p orbital, px, py, pz, the electron pairing takes place only after all the orbitals are singly filled. Okay, that is based on spin multiplicity. What is spin multiplicity? They will ask in spin multiplicity. When S is the total spin, for example, total spin 1 by for nitrogen atom, each orbital, each px or px, py, pz have one electron. Therefore, 1 by 2 plus 1 by 2 plus 1 by 2, 3 by 2. Therefore, 3 by 2 into 3 by 2 plus 1. The spin multiplicity is calculated like that. Okay, total spin. Suppose in one orbital, one spin is spin and another is downward spin, then minus or plus of 0 it will become. Okay, magnetic moment can be calculated by using this formula. Spin only magnetic moment. Where mu is the spin only magnetic moment is calculated by using the formula n into n plus 2 Bohr magneton. By calculating the magnetic moment, magnetic susceptibility, we can calculate the magnetic moment and number of unpaired electron. We can determine the electronic configuration. Or from the electronic configuration, we can calculate. You will be asked to calculate the magnetic moment of an atom. Spin only magnetic moment of an atom. Okay, now let us come to an important topic: photoelectric effect. Einstein discovered this photoelectric equation. He was given Nobel Prize. He was also given Nobel Prize for his famous E is equal to mc square relation, relative mass theory of relativity. E is equal to mc square. This effect is an evidence for particle-like behavior of matter. Okay, particle-like behavior of electron. Now, what is when a light beam falls on electropositive metals? When a light beam falls on electropositive metals, for example, alkali metals, alkaline earth metals. Okay, they are the electrons can be easily ejected. the electrons can be easily, because the electrons are loosely bound, the ionization energies are less, they are ejected. The ejected electrons are called photoelectrons. They give for current, photoelectric current. They give photoelectric current. This is the basis for photoelectric cells. Okay, he was given Nobel Prize for this equation. For example, when a beam of a part of the energy, you are giving a quantum of energy h nu. You are giving in the form of light radiation. A part of the energy is used for dislodging the electron, for removing the electron, from the atom. That is ionization energy. And the rest of the part of the energy is transferred to the electron as kinetic energy. This was his famous equation. It earned him a Nobel Prize. Okay. So what is h nu naught? H nu is the intensity of the light, the frequency of the light, incident light, the frequency of the incident light, the energy of the frequency of the incident light, and this is the threshold. Nu naught is the threshold frequency, or h nu naught is the threshold energy plus kinetic energy of the ejected electron, emitted electron. Okay, now the photoelectric current is directly proportional to the intensity of the light, intensity of the incident light, and the kinetic energy is directly proportional to the frequency of the incident light. And the stopping potential V naught equal to 1 by 2 maximum kinetic energy, that is maximum velocity 1 by 2 mv square. These are the various formulae you may be used to solve your problems. Okay, now let us come to Davisson-Germer experiment. It is an illustration of wavelength behavior of matter. For example, when a metal filament is heated, it emits electron. Okay, the electron is accelerated by applying voltage. Therefore, the kinetic energy is equal to EV. The kinetic energy of the electron wave is EV. When the electron falls on crystal, for example, nickel crystal or any crystal where the interplanar spacing is known, the interplanar distance is known, and theta is the glancing angle. Theta is called the glancing angle, and n is the order of the reflection, and lambda is the wavelength, and 2d sin theta is the path length difference between the two waves falling on successive planes. Okay, now using this is nothing but Bragg's equation. Bragg was awarded Nobel Prize again for giving this equation, and also X-ray. He used X-rays to study the crystal structure, to study the arrangement of atoms in the crystals by using this formula. Okay, now what you know kinetic energy, because you know charge on the electron. This is nothing but charge on the electron. We know the voltage. We apply the voltage to accelerate, to produce the electron waves. Therefore, you can calculate, for example, Planck's constant, to mass of the electron, you know, charge on the electron, you know, voltage applied, you know, you can calculate the lambda. And from you know, again, you know the theta. Theta is the angle at which the maximum intensity is obtained for first order reflection. Therefore, you know, lambda can be calculated. So you can obtain lambda from this expression, and lambda from this expression. Interplanar spacing for nickel crystal is known. Therefore, it agrees with each other. Therefore, it proves that the electron waves are nothing but have wavelength behavior. Okay, next, Compton effect. Arthur Compton, American physicist, was again awarded Nobel Prize for this equation. For what is his experiment? Okay, according to his experiment, when a beam of X-ray of monochromatic wavelength, falls on electronegative element. In here, electropositive element. Here, electronegative element. Light, for example, carbon atom. Electronegative elements. What happens is the incident beam interacts. The incident X-ray interacts with the electron of the atom, and because of the interaction, there is the scattered radiation. The scattered radiation the scattered radiation wavelength is measured. Okay, this is the lambda naught is the wavelength of the scattered radiation. Lambda is the wavelength of the incident radiation. Lambda naught is the wavelength of the scattered radiation. Okay, after when it falls, the light is scattered. The light is when the incident beam, when the incident X-ray beam falls on of monochromatic wavelength, falls on falls on electronegative elements, the scattered light is emitted. The scattered light emitted wavelength is actually greater than the incident wavelength, and this is called Compton shift. And the Compton shift, the shift in the wavelength is called Compton shift. H by mc 1 minus cos theta, where theta is the angle between the incident light and scattered light. Scattered light and incident light. For example, incident beam and scattered beam, theta is the angle between the incident and scattered beam. Okay, now theta is the scattering angle. Now you see here, this effect illustrates both particle-like behavior and wave-like behavior. Okay, for example, in the case of photoelectric effect, it illustrates particle-like behavior. Davisson-Germer experiment, it illustrates wave-like behavior. Whereas in this case, this experiment corresponds to evidence for both. For example, you have wavelength, and also because of the interaction of X-ray with the electron in the atom. That's why mass of the electron. This is M is the mass of the electron. C is the velocity of light. Okay. As a result of that, there is an elastic. There is a conservation of momentum similar to particle-like behavior. And when theta equal to 0, if you put cos theta equal to 0, then it will be cos theta equal to 1. Therefore, 1 minus 1, 0. Therefore, the Compton shift is 0. That is, when you measure the Compton shift in the same direction, the scattered radiation wavelength is measured in the same direction as the incident radiation. Then it is 0. Now, okay, you are here and you are measuring perpendicular to the scattered light is measured perpendicular to the incident light. Here you are measuring the scattered radiation wavelength. The wavelength of the scattered radiation, this is perpendicular to that. Therefore, theta equal to 90 degree. Therefore, delta lambda equal to cos 90 equal to 0. Therefore, h by mc, this wavelength is called Compton wavelength, and theta equal to 180 degree when the incident when the scattered radiation is measured opposite to the incident beam, then cos 180 equal to minus 1. Cos 180 equal to minus 1. Therefore, you will get minus 1, 2 by 2h by mc. It is twice the Compton wavelength. This wavelength is called Compton wavelength. In general, the scattered radiation is measured perpendicular to the incident beam. Okay, this effect is very similar to Raman effect. Raman also studied similarly when a light beam falls on a substance. It will also the wavelength is of the wavelength of the scattered radiation is shifted because some of the radiations why it is shifted. A part of the energy is lost because it causes rotational transitions or vibrational transitions. He was also awarded a Nobel Prize. We will see in the next class. Compton effect is also a very important question. So these are the various formulae. These are the various formulae. I request you to write down in your notebook so that before you go for competitive examinations, you can quickly revise. Thank you very much for watching.